Welcome everybody to the latest of our CODA webinars. I'm absolutely delighted to welcome one of our new partners, IKM, and through that to welcome both a familiar face in Shaun Sadler, who many of you will be more familiar with being in the role that I'm doing on here, and also Jan-Erik Eriksen, both of IKM. Quick introduction for myself. I'm Francis Norman. I'm the CEO Managing Director with CODA. And for today's webinar, we're going to be hearing all about topside steam cleaning, global experiences and key lessons learnt from IKM Testing Australia Pty Limited. So Jan is based in the UK, and Shaun, of course, is based here in Australia. So without more from me, I will hand over now to Shaun to kick us off.
Very good. All right, thanks very much indeed, Francis. It certainly does feel a little bit strange to be on the other side of the process, but we really do appreciate the opportunity to share some of our experiences through the CODA platform. Hello everyone, my name's Shaun. I'm Head of Business Development here at IKM Testing Australia. And over the next half an hour, 40 minutes, my colleague Jan-Erik and myself, we're going to provide you with some insights into the use of steam cleaning for the removal of hydrocarbons as part of the overall decommissioning workflow. So just bear with me, I'm just going to share my slides into the meeting. Hopefully you can all see that. Good, so we're going to start off by me telling you a little bit more about IKM Testing and placing our Australian business in the context of the broader global IKM group. And this is really important because some of you might be thinking, who are these people and why am I here to listen to them? And I need to sort of provide that more global perspective and the more global look at IKM's decommissioning experience to place in context what you're going to hear then from Jan-Erik. I'll hand over to Jan-Erik after that. He's one of our senior technical advisors from IKM Testing in Norway. And he's going to talk in more detail about the steam cleaning as a process. He'll focus on how it works, what it does, what sets it apart and makes it different. And we'll also be happy to bring you a large-scale case study of its deployment in the North Sea. At the end then, the food for thought, I'll come back and I'll bring us back to more of an Australian context. And I'll leave you with an opportunity to think about. And after that, we, of course, really welcome your thoughts, feedback, and questions. So first, a little bit from me about IKM Testing Australia. We've been operating here in Perth for almost 20 years, established in 2006, providing services to what was then a growing oil and gas industry. And IKM Testing Australia, often known more commonly as a pipelines and pre-commissioning services company. But over on the left-hand side of this slide, you'll see a more diverse set of services. So pipelines, together with nitrogen services, inspection, testing, pumping, flushing, and cleaning. All of these services can be scaled and combined in different ways and lined up around different types of activities at any stage throughout the project life cycle. So IKM Testing Australia deals with a very diverse set of opportunities and delivery into pre-commissioning, operations and maintenance, and through into decommissioning.
Very good.
And we work both onshore and offshore environments, focused on facilities, but we also support wells operations. In terms of Australian offshore decommissioning, our most recent experience is mainly in the conventional flushing and cleaning of subsea infrastructure prior to its cutting and removal. So not actually the steam cleaning part that we're going to talk about today, but we'll come back at the end and talk a little bit about that in more of an Australian context. So as I said, IKM Testing Australia is part of a large global organization headquartered in Norway, which operates in 14 countries worldwide. Our remit here in Perth is Australia and New Zealand. And we also have IKM Testing Asia and IKM Subsea based out in Singapore, who support the rest of the APAC region. So we're out here, we're part of this larger global organization, which has a lot of experience in other parts of the world as well. So in terms of the broader organization, really aim to establish itself as a competent, cost-effective service provider to the energy sector, supporting a very wide range of activities and extending into adjacent industries and even picking up energy transition opportunities increasingly. But here today, we're talking about decommissioning. And I think that's really important. I think decommissioning has played a critical role, a foundational role in the growth and success of the IKM group worldwide. And this is the piece of context and perspective that I want to talk about before we start into the detail around steam cleaning. IKM Group's been involved in decommissioning for almost 25 years, largely in the North Sea area. And in that time, they've developed into, as you can see here, Europe's largest supplier of offshore decontamination services and the world's largest supplier of offshore steam cleaning services. So we have very substantial and long-term experience of deploying steam cleaning into both turnarounds and decommissioning operations. And that's the backdrop against which we want to share some of that global experience into the Australian business today. So what I'm going to do now is I'm going to stop my slideshow, and I'm going to stop sharing, and I'll ask Jan-Erik to step in and share his screen and pick up the story from there.
Thank you, Shaun. So good afternoon to Australia, and good morning to Europe, and hello to everyone in between. My name is Jan-Erik Eriksen, and I'm the Senior Technical Advisor at IKM. And I've been working here now for almost 30 years. Been involved in steam cleaning for roughly 27 of those years, and in topside decommissioning for 24 years now. And today we're going to talk about steam as a cleaning agent, and we're going to do that in the context of topside decommissioning. But before we do that, I would just like to say a big thank you to CODA for hosting this webinar. It's really appreciated, and a big thank you to all of those who have joined us. We will do our very best to make it worth your while. So let me share my screen with you. So we're going to talk about steam cleaning, and so it's going to be, a bit technical, not too technical, but we are going to go into how it actually works. We're going to look at the benefits, both from an operational side, but also what it means to your project, how it adds the value. And we're going to give you a case study. And as I'm sure you can all agree, anyone from the supply chain will always tell you that they have the best methods, the best technology, and the best equipment and all that. So that's why case studies are so valuable. The proof is in the pudding, so to say. And luckily for both you and for us, we have Europe's largest decommissioning pudding to share with you. So if you like pudding, just stay there and we will get back to you. But we're going to start out with a little bit of the backdrop, the pedigree of steam, a little bit of history, how it's developed and where it is today. And there's good reasons why we do this, because it's not the first time we introduce a service to a new market. And what we have learned is that when we introduce a technology to somebody that's new to them, they kind of think it's new in general, that the technology is new. And when it comes to steam cleaning, nothing could be further from the truth, because this was introduced to the Norwegian sector more than 40 years ago by Phillips Petroleum, and they again took it from the USA. So this is a very mature technology. And I remember being out there on the Ekofisk field, this must have been late 1990s, watching this being done. And I also remember saying to a colleague that we could do that better. And as it turned out, we could, because shortly after, IKM ventured into this service line, and we straight away set out to improve this technology, to take out all the potential we could see in it. And the operators in Norway must have liked the result, because fairly quickly this became the default method for removal of hydrocarbons in Norway. So today there's not a single turnaround in Norway that doesn't use steam. We supply it to all in all more than 37 turnarounds now, mostly in Norway, but also in the UK, in Brazil. And it's also used for all our decommissioning projects, except one. The latest one was not used steam, and that had an explosion when they started cutting the vessel, so I don't think that's going to happen again. So this is, we have now done this worldwide for 35 topsides doing decommissioning. Right now, most of that is actually not in Norway, because we don't have too much decommissioning going on right now. So we did 2 projects in the UK only this year. We have 1 ongoing project in Brazil, and we did 1 last year, and we have several one in the pipeline, both in Brazil and in the UK. And as mentioned by Shaun, we are the world's largest supplier of this service. And you can see here now with all the turnarounds we do year in, year out, we have now reached almost 3,000 separators and vessels who's been cleaned by steam. So all in all, a very mature, very well developed technology that we know very well. It's bread and butter stuff for us. So we're going to start out by looking at the operational advantages. Then we will look at what this means for the project later on. And the most important factor here is, of course, that steam is by far the most efficient method we know about and that we have available for removing hydrocarbons. And I guess it's quite intuitive, but this is linked to the heat, of course. When you heat something up to 100 degrees plus, of course, you will flash off lighter fractions of hydrocarbons in an enormous amount compared to what you would do with the cold nitrogen. And what also happens, of course, when you heat it up is that you lower the viscosities of the heavies. So this make it stand out compared to what's called DFPV, drain, flush, purge, vents, which is the traditional method of at least initially removing the hydrocarbons. We are removing both the light and the heavy fractions in one go. And as you will see later on, that has impacts for the whole project. Much more than just the FPV stage. So those 2 are very important. The third point here is also very important, especially for decommissioning projects. Because when you do a classic DFPV, there will be remaining hydrocarbons. You know, the wax is still there, heavy crude is still there, it's still inside your valves, heat exchangers and all sorts. And you now have to clean them out with other methods, typically by jetting. Jetting is the most used method around the world for some reason we don't understand. But to do that, you need to remove quite a lot of inline equipment. Not so with steam. We can steam through anything. We steam through flow meters, tubing, heat exchangers, all sorts of valves. Anything that can handle gas can handle steam. And this, of course, is a major advantage because you eliminate the whole rigging campaign during cleaning. You don't need to rig out anything. Only thing we sometimes remove is some safety valves. They represent high points that we need. Other than that, everything stays in place. And that has a big impact on the workload, but also on safety. It's better to leave things in place than to rig them out. What it also means that we can steam through all this equipment is that we can steam and clean very large segments at a time. Unlike other cleaning methods where you clean kind of pipes here and a pipe there and then you need to rig out another valve or whatever, we can just steam straight through it. So we can clean large segments at a time. I'll come back to how large. It depends, of course, on several factors, but it's pretty substantial. We can, for example, with a couple of steam units, we can steam through a whole oil train in one go. Another thing that is worth mentioning is the small equipment footprint. The photo you see to the top right here is a steam unit. It's 1.8 megawatts and it's fitted into a 12-foot container. So 1.8 million watts in a 12-foot container. That's pretty hefty. And the largest hoses we use for steam injection is 2-inch. So you can see the bottom picture here, that's the largest steam manifold we have. The only other equipment we use are hoses we use that is larger than this. That's typically 4-inch hoses, but that's to drain large vessels to get rid of sedimentation. We can actually remove a lot of sedimentation during the steam cleaning. So other than that, this is small footprint and very, very efficient process. Last but not least, IKM provides more or less every cleaning service under the sun, and none of them has a better HSE record than steam. And this may be not so intuitive. People think that with all the heat and energy that it will be a dangerous service. It's not. And to be honest with you, the heat, I don't think have ever given us any incidents. So the few incidents we've had has been more linked to spillage and stuff. I don't think we ever had a single medical injury that required medical attention or first aid attention during steaming. It's a very, very safe process. So that is some of the main kind of operational advantages we have. And what also happens, here we can see a little bit about what it means. All these pictures are taken after steaming, but before manual cleaning. So this is how it looks when you open it up. And I'm not going to lie to you, these are the bragging pictures we have. We have much more than these two, but not every vessel looks like this because depends on a large range of factors, of course. You know, stainless steel is easier to clean than carbon steel. It depends on what kind of contamination you have. It depends on the configuration of your equipment and vessels, but generally they are very, very clean compared to what you would be used to if you don't use steam. So you can see now why this became very popular in the Norwegian sector very quickly, and we'll come back to now what it means for the projects when it looks like this. Very clear. And I guess the main advantage of all these is the reduced or eliminated cleaning campaigns further down the line. So, as I said, since we are removing also the heavies here, not on the waxes, you know, the asphaltenes, all that, not only the lighter fractions like you normally would do with the DFPV, it means that you can simply eliminate further cleaning campaigns. And this is where it gets complex, I must admit, because how this plays out in a decommissioning project will depend a lot on the moving parts we have. Is this a fixed installation? Is it an FPSO or a semi-sub? Is it a single lift-off, a modular lift-off? What kind of contract do you have with the receiving yard, you know, the recycling facility? All these things will come into play here to define how much you will gain from using steam. In my experience, you will always be better off than using more traditional methods, but how much more? Well, as I said, it depends on a large range of factors. And we will look at this, of course, when we come to our case study to look at some of the specifics for that job. One of the things we can say is that when you do a classic removal of hydrocarbons, you will have a fairly long vent period. I'll come back to that too. That is not the case with steam. As soon as it's finished steamed and cooled down, you won't have any more hydrocarbons flashing off. You can start your hot work or whatever you want to do immediately, which of course is a good thing. I'll show an example later on about how this either eliminates or minimizes vessel entry, saving an awful lot of man hours, but also a safety aspect there. You know, we don't want people in vessels more than we have to. When we use steam, we don't need to handle norm or mercury offshore. Whether that is an upside or a downside, that depends a bit. As you will see from our case study, it was a massive upside that we left all the norm and mercury in the plant. We don't get that out when we steam. If you do jetting or other services, cleaning services, you will more or less automatically get these contaminations out at the same time. Not so with steam. As I said, whether or not that is an advantage depends on a range of factors. And it's also much safer. You know, as I said, we recently had an explosion in Norway, but it had not been steamed. So With steam, you won't have the pockets of hydrocarbon left in the process plants, and we won't be venting VOCs and benzene onto deck. Maybe I can say a little bit about that. No, I can do that on the next slide, actually. I think we have it there. Yes, we do. No, first this one. Okay. Here's an example from a vessel, a specific vessel. These are all from the same vessel. Pictures are taken, two of them are taken in 2021, and one is taken in 2023. And the operator has said that this coalescer has always looked like this when they open it up, for the last 10 years, like it does on the left side here. And in 2022, I took a trip to Brazil and spoke to the operators and explained to them pretty much what I'm explaining to you now. And we were allowed to showcase this for them. And you can see the result, And again, I'm going to be honest and say this is quite an extreme example, though, because as such, steam cannot remove scale. And this looked like it's scale. As it turned out, it wasn't. This is sand and minerals bind together by hydrocarbons and wax, and it's solidified like this. So prior to steaming, they would use 728 man-hours, to simply hack and jet and remove this manually. What happened on the right side here, when we can heat this up to 100 degrees, this turns into slush again, not solidified. It's more like slush, and we can now take this out by using vacuum from the outside. So this is how it looks when it's opened up. And now you can see what I was pointing to when I said reducing man-hours. So we might add a little bit of time for steam in the beginning, but the man-hours you will reduce, and the workloads you will reduce further down the line is very substantial.
Very good, very good.
So where does this steam fit in the process then? Okay, normally we would do it as the part of the very early stage, the DFPV, which comes very early on in the engineering down and clean process, just after COP normally. And we can see here how it's the traditional one on the top here, drain, flush, purge, and vent. And the thing is here that, when you say the vent, it sounds so easy, doesn't it? You just vent it. But it's not really, is it? Because this is pressureless now. All your check valves are now closed both directions, and you have just flushed this with water, the system. Any dead legs with water in the system will stop you from venting, and you won't have any draft through it. So if you're going to do a proper venting, that is actually quite a complex job to do. Another thing is that for me, who's worked a lot offshore, we spend so much time trying to avoid methane on deck leakages. And all of a sudden we think it's a brilliant idea just to open it up and let it onto deck. And it isn't a brilliant idea. It's still just as bad as it's always been. They say V is for victory. In this case, V is for failure, isn't it? Because what it means is that the first three processes, the drain, flush, and the purge, didn't succeed, did it? That's why we have to vent out the rest. It's more in desperation than anything else. We don't have a way to get rid of it. But now we do. We can use steam. We pretty much replace the vent there with steam. And that, yes, will add a little bit of man-hours in that process. We have add another service line in there, typically a day or two. But when we look at what that does to the overall cleaning scope, well, the benefits and the reduced man-hours are very substantial. So for us, even if this is the kind of the default method, the classic DFPV is the default method still in most of the world. But in our opinion, it's not fit for purpose and it's not safe, venting out VOCs, benzene on deck. It's more out of desperation than anything else. So this is where we fit in. That said, we also perform steam cleaning for the yards, recycling yards. When they receive their installations, they know they haven't been steamed and they know the dangers, so they ask us to come and do steam at that stage now and then.
Very good, very good, very good.
Now we can go into a little bit about how it actually works. And for all steam cleaning, either we do a single vessel or we do large segments like we typically do during decommissioning. we need three networks. We need steam injection, we need vent, and we need drain. I'm going to show you some animations soon now to see how this works, but basic principle is that the lighter fractions of hydrocarbons will flash off and we can remove them through the vent, while the heavier fractions melt down and we can drain them out. So principle here is fairly simple. Let me see if I can get these animations to play. So here we have a simplified separator, and I will stop as we go along and give some comments.
Very good.
So, as I said, it's fairly simplified, but still, we can maybe stop there. Here you can see the three networks we have. We need to have the vent on the high point to get rid of the lighter fractions. We need drains, which are the blue ones, to drain out condensed steam, but also the heavies that melts down. And we need steam injection. Steam injection can be, we like to have it in the bottom and normally on the sides and sometimes on the top. It all depends a bit. It's not very critical.
Very good.
So we start now heating this up. First we drain it as much as we can. And now we start introducing steam. We have toned down the steam a bit here now, although the whole vessel will be full of steam, of course, but we toned it down a bit for clarity. And as I said, now when we start getting up to 60, 70 degrees, the lighter fractions will start to flash off. They won't really leave the vessel at this point, because at this point we have 0 bars on it. Until we reach 100 degrees Celsius, we will have 0 bars, but they will flash off into the atmosphere here. At the same time, the viscosity of the heavies starts to go down, so they literally melt off, and they will now hit the bottom, where we also have some water from the steam, and this functions as a slide when we now drain it out. So we slide the heavy hydrocarbons on top of the water and out.
Very good, very good, very good, very good, very good.
So we keep on heating it up. As you can see, we reach how high we go will depend on several factors. I can come a little bit back to that. And yeah.
Very good, very good, very good.
And we've been quite honest here. We have left a little bit of sedimentation because that is very often how it is. We can't flash off sand, can we? So we will be able to remove a lot of it though, and I'll explain that. We have something called a boil out, and
very good.
It's a bit technical, but the thing is that for steam, the pressure and the temperature is a function of each other. So if you tell me that you have half a bar on your vessel, I can tell you that you have 111.37 degrees Celsius on your vessels. And we can utilize this. So what we do, we stop our draining for a while. So we build up a layer of water in the bottom of the vessel. And then we close the vent and we build pressure on the vessel. And we normally do that till we have 120 degrees on the shell side. Since we now have pressure on the vessel, typically a bar, we actually,
very good.
The water won't be boiling due to the pressure. Then we flash open our vent, and what's happened then is that all the water that has penetrated through the sedimentation now expands 1,700 times. The expansion factor when you start boiling. And you can actually hear this from the outside. It starts rumbling inside this vessel. And that's exactly what we want, because one of the really hard parts when it comes to a hydrocarbon-free this vessel is to get rid of all the trapped hydrocarbons in the sedimentation. But now we are moving it. We can hear the rumbling. We can hear the mechanical movements inside there. And that's exactly what we want, as I said. Now we are freeing up a lot of hydrocarbons and lighter fractions, but we also help cleaning out and loosen all this, all the heavies. So what we achieve is that we can now use vacuum from the drain points on the vessel. And this sedimentation that used to be very sticky, muddy stuff, now is much more like, I wouldn't call it beach sand, but it's much closer to that, which means that we can now get out an awful lot more sedimentation from the outside than you would ever do with any other method. So how much depends, but 50, 60, 70% of the sedimentation can be removed during the steam cleaning typically. And we don't know of any other method that can actually clean out sedimentation without entry. So this is something that's highly efficient, and we will again see it how we did that on our case study. Here we have a larger system. Principle is exactly the same. We just wanted to show you that what I mentioned, that we can steam through large segments of pipes, heat exchangers. It doesn't matter. We can go through all this, but the principle is exactly the same.
Very good, very good, very good, very good, very good, very good, very good.
Yeah, we can see here now the heat steam coming in, starting to travel through the pipes as it heats up. And again, we will do the same, drain out the heavies and flash off the lighter fractions and take them out the vent. So not complex at all, really. It's a very good fairly simple principle. Yeah, let's have a look. So, our case study. Yes, the Tyra redevelopment project, Europe's largest decommissioning project to this date. It consisted of 2 large field complexes, Tyra West with 4 installations, Tyra East with 5 installations, and also 5 bridges in total. They had an awful lot of pipe work on those bridges. You know, some of these installations even have double bridges. So a very big project and a very successful project.
Very good.
So a few more fun facts here. It was the world's largest offshore steam operations. We had 7 boilers in work in parallel on top. We used 32 days on Tyra West, 39 days for Tyra East, and all in all, we treated 3 million liters of water that was sent to sea. So some fairly big numbers here.
Very good. Very good.
So what was the task? Task was removal of hydrocarbons in all wet hydrocarbon systems. And why do we say wet hydrocarbon systems? Because we don't really need to steam the gas drain. You know, the classic purge would normally do the job there. We can do it sometimes, it can be faster, but we don't really need to. So what we steam is the oil train, the produced water, and glycol regeneration, flare system, drain systems, all those systems are included. In this case, they did not have any route for us for the waste, so we needed to treat that offshore and release it to sea, whatever was cleaned. And we did all the detail engineering and planning for this work. Maybe I should mention also that I'm a Topside guy, but IKM also did all the pipelines here, all the 26 pipelines. The criteria was to reach 5% LEL. Effluents had to be below 30 ppm, and all in all, we were given 8 weeks to clean all the 9 installations.
Very good.
I mentioned that we could do large segments at a time here. I think I remember that this pretty hefty installation here, the main production platform on the east, I think we split that in 8 envelopes to do all the systems, hydrocarbon systems, to just give you a feel of how much we can steam at a time.
Very good, very good.
So what did we achieve? Well, the client here, this was in Denmark, I forgot to say, and the client here was Total Energies, and they did 201 measurements for hydrocarbons, and the average LEL was 0.3, which is 16.7 times better than the 5% acceptance criteria. So that is very good, of course, but for me, who's been working for steam so long, that was pretty much what I expected. But what was more impressive, I found, was that there were 62 vessels there, you know, and pig receivers and pig launches on these installations, and not a single one was opened or entered, not one. They were all cleaned from the outside, and they still achieved these results. Also mentioned that we did not handle any norm or mercury offshore here, and this comes back to what I said about the contract you have with the receiving end. In this case, it was what we call an as-is contract, meaning that the yard was willing to receive this with the contamination it has, as long as the LEL level is below 5%. Anything else can stay put. And of course, for our client then, it was a massive advantage that we didn't have to mess around with normal mercury or anything else offshore. If this had been done by jetting or anything like that, you would have had to do that. No, you have no choice. In this case, they can get really, really good LEL measurements, but without having to touch anything else. And again, we did not remove any inline process equipment except for some PSVs.
Very good.
We cleaned all the water, and approximately 20 cubes were sent onshore, and it was delivered on time and on schedule. So a very successful project for us and for the client, and also know that the receiving yard was very happy. They had never received a steam cleaned installation before, and it saved them a lot of cleaning too. So the steam cleaning has knock-on effects all the way through.
Very good, very good.
Lessons learned, yeah. The first one here is not really from Tyra, but it's one of those we see maybe most often, and that is that asset owners, or sometimes even tier one contractors, they don't have the comprehensive and holistic understanding of decommissioning projects early enough. They will get it at one point, but they don't have it early enough. And that is a big problem, because what happens then is that they treat the decommissioning project as successive operations with some certain dependencies. And that's of course what it is in many ways. The problem is that you have what we call cross dependencies. You know, one of the first decisions you make affects some of the last operations, meaning that if you just set out doing from A to B to C to D, you won't catch the links between A and Z. And that means that yes, you will get your project decommissioned, your installation will end up in the steel mills, but not in the most cost efficient way. And that this is a big problem for the industry, this lack of holistic understanding from a very early stage. But that's the subject for another webinar. The next one is actually from this project, early involvement from cleaning contractors. And it was Maersk Oil and Gas who had this originally, and they did the first part of the planning for this decommissioning project, but then they were acquired by Total Energies, and in that process there was a delay, which meant that we came in about 9 months later than we should. And in the meantime, Total had defined what they called safe state areas, which is basically how they're going to declassify this. There's different ways we can do that. Many people use the EI code 15 in reverse mode, but there's other ways you can do it. And Total had made their own safe state areas, which they declassified as they went along. The problem was that these did not align with our steam envelopes. We have certain requirements for vent and drains. And Maersk, they actually knew this, and they told us this, that they should have done it the opposite way around. We should have made the steam envelopes, and they should have then had one-to-one with their safe state areas. And this increased the workload on engineering with roughly 50%. So getting a cleaning contract in early, even when you start doing contracts with your receiving party, you know, the recycling yard, having some input from a cleaning contractor already then could be well worth it. Another thing we see, and that surprises us quite a bit, is that there's very little changes or adaptations to the regulation and controls offshore when you do decommissioning projects. And that's strange, because there's an awful lot of restrictions and restraints and controls when we do offshore work. But that's all based on high risk level, when we have full production with large inventories of hydrocarbons, pressurized hydrocarbons. But that changes through the process, doesn't it? And you can see the risk profile changing here. So why keep that up? It's very it costs a lot of money to keep those controls up. So what we did on Tyra was to change the controls, as you can see down here at this stage here with 20% LEL. How this worked was that we had two forms. One that we signed, as I think it was called system takeover form. That meant that IKM was given the control over this certain segment. meaning that Total signed for it was being drained, it was pressureless, and so forth and so on. And as long as we had that signed, we could then swing the valves, we could connect as we wanted to the process systems without any assistance from them. It increased efficiency quite a lot, also reduces bed spaces needed by operations that we could do in use instead. When we were finished with this certain segment, we handed it back to Total, again with a form, meaning that now they own it again. We cannot do any work on that anymore without specific work permits as normal. That's one way of doing it, but we are missing an opportunity here by keeping the controls as if we had normal operations all the way through, as long as we are offshore. There's no need for that.
Very good, very good.
So we are getting to the end here. Here we have a list of some of the projects we've done, but we also become very active in the, what should I say, in the kind of decom community, doing talks on the major oil and gas conferences. Last one was OTC in Houston, now in May. Anyone interested in how we can reduce post-COP OPEX, just give me a shout. We published quite a few papers now to the Society of Petroleum Engineers. They all revolve around decommissioning. And one of them was awarded the best prize for the best technical paper by the Brazilian Institute for Petroleum and Gas in 2022. And we are currently setting up the largest onshore facility for decom in Brazil. That's going really fast and moving fast forward, and it's very interesting, at least for us.
Very
so
good.
I think that was it from me. I hand it back to you, Shaun.
Good.
Thanks very much indeed, Jan-Erik. Yeah, I'm just going to share my slides back in just as we close this up. As we bring the presentation to a close, I want to bring it back more to an Australian context. And here we see where are we up to with our decommissioning journey, and here's CODA's excellent forward outlook. We're well underway in the first major wave of offshore decommissioning here in Australia, but what this also shows us is that still going to be plenty of work to do over the next couple of decades. And that brings us to, we've heard a lot about steam cleaning, the way it's been deployed throughout the North Sea to great effect. And of course, we're starting to wonder, is this something that we can pick up and bring into Australia potentially to improve the efficiency of decommissioning operations here? So we're actively seeking candidate pilot projects for the application of the steam cleaning methodology that you've talked about. A couple of key things here. Firstly, candidate pilot projects don't have to be associated necessarily entirely with whole asset decommissioning. As Jan-Erik mentioned, this has been very successfully applied to turnarounds. And indeed, turnarounds could actually be an ideal sort of pilot for this type of work. And I think secondly is that it's just to emphasize again, this is not necessarily rocket science. We didn't invent it, but we do have a lot of experience of applying this. It is a very portable technology, basically. It's an established process. And it can be readily engaged with local supply chains as we take it into different parts of the world. So if we are lucky enough to actually get a pilot project up and running sometime next year, for example, we're not necessarily going to be shipping lots and lots of steam generators over from Norway. We're going to be looking to the local supply chains to support that and support its capabilities. And I think that's really important. The way that steam cleaning can effectively be ported into different regions and actively engage with the local supply chains to support it.
Very good.
So that's as much as we wanted to give you today. Only remains for me to thank CODA, thank all of you for your time and attention, and we're very happy to answer any of the questions.
What also
good. Thank you both, gentlemen. That was very, very interesting. The case study, I found the case study particularly very interesting in there. We have had a few questions come through, so I'll start off with those. and I'll read them out in order of appearance, for want of a better term. So the first one here is, can you tell something more about Kirasol 340?
What also happened? I can also see that there is another question related to chemicals. So I think I'll take both in one go. Yeah, Kirasol 345. Yeah, no, we use chemicals in steam, but not necessarily always. That all depends on the scenario. They can be quite efficient when it comes to, especially with vessels with a lot of heavy contamination. Then we can see the benefits definitely using chemicals. We would not use it just to use it. A, because it costs money. B, because it also has an effect on separation. So we need to take into account how do we handle all the effluents we have. And I can say a little bit about that too. We produce roughly 1.5 cubes effluents per hour of steaming, which doesn't sound very much, but of course if you steam 9 installations like we did on Tyra for days in, days out, yeah, it adds up. You know, we saw the 3 million liters that we end up with. So we always need to weigh this up. Are we going to use chemicals or not? Based on what kind of contamination do we remove and what is the waste route we have. If we have a waste route that allows us to use chemicals without thinking about separation, well, then we quite often use it. We do. I can say that we use roughly, for one large vessel, let's say we have a separator, 200 cube separator, we would use 1.5 cubes of chemicals. So not massive amounts, nothing compared to what you would use when you do chemical cleaning. Very small amounts compared to that, but still a bit. So yes, Kirasol 345 is our preferred chemical for this. We've been using this for almost 20 years now in steam. It's a benign chemical, you know, it's no special pH or if you get it on your skin, you don't get any rashes or anything. So it's a nice chemical for us to use, and it's highly efficient on asphaltenes, waxes and stuff like that.
Very good, thank you. So you've done the next question there in conjunction with that one. The next one here from Craig, when does steaming start? After COP, drain depressure, nitrogen purge or no nitrogen purge? Okay, I'll work through that one. Yeah,
I did kind of cover some of that, you know, that it comes in as part of the DFPV normally. We call it DFPS, drain flush for steam. But the question about if it replaces nitrogen, that's a good one, because in one way you could think that it does. We remove the hydrocarbons far better with steam than with nitrogen, but it still doesn't completely. And the reason for that is that during the drain flush purge vent sequence, you use the back pressure from the nitrogen to really empty your system properly. So that means that a typical purge will consist of 4 to 5 pressurizations. And you can probably skip all of those except for the first one. You need the first one for the proper draining, as back pressure to drain it out. After that, we don't really need the purge anymore, because after that it's just to get the LEL level down, and that we can do much better with steam. So you can reduce it dramatically, but not completely. And that's my advice on that.
Very good. You still need your nitrogen systems live and so forth to support that, yeah.
Could maybe mention one more thing, because I mentioned we're setting something up in Brazil, something we call a pre-dismantling station. And what we're saying now is that basically we should do no cleaning offshore. Nothing, not even the hydrocarbon removal. Why can we not remove these hydrocarbons onshore if we can do exactly the same job offshore? Of course we can. We can do it faster, cheaper, safer onshore. As long as the only reason why we do this offshore is that no yards will accept your installations coming in with 100% LEL, but we will, no problem. We can do this just as good onshore as offshore. And the reason why we're doing this is that the cost for decommissioning, if you look at the cost for topside decommissioning, it's not related to the cleaning campaigns or pipeline campaigns, even not the recycling. It's linked to post-COP OPEX, how much it costs to run these installations after COP. We have examples, especially from Brazil, where they've been out there for years after COP, costing $100,000 a day. It's expensive. We say no floating installations, no FPSO, no semi-sub should be out there for more than 6 to 10 weeks. No reason for that. And you need to have good reasons for it. Otherwise, it should come straight in onshore. All cleaning should be done there. So that's again a different webinar, because we want to change the whole way we are organizing our topside decommissioning, especially for the floating installations. It's not being done very smart for the moment. It's yeah, but that's another webinar for we can set up, Francis.
Sounds like you're setting yourself up for a series here, Jan. We'll have to get a block booking for you. That was great, thank you. So the last question that we got again from Craig was around water cleanup. So was water cleanup done utilising steam or an alternate method?
Very good. Very
I
good.
guess that refers to the effluents we're producing during steaming. No, that's as I said, very important. It's a major part of any decommissioning project, regardless almost of what cleaning method you use, is to handle the effluents that you will have, because you will have quite a bit. If you prefer to do it by jetting, which you shouldn't, but if you do, it even produces more water. So handling that is very important. And if you don't, we have a kind of a pyramid there, preferred methods is always to get rid of it offshore through either a waste well or through any other means you have, pumping it into a pipeline. That's always the fastest and the cheapest. But if you don't have any of those, and in this case we didn't have any other waste route, then we will mobilize a wastewater treatment unit, which actually separates oil and water very efficiently. I think we were down to an average 2 ppm of what we released. And in this case, we didn't have too much solids on board, so it was very efficient. We ended up with almost nothing going onshore, and 3 million liters being sent overboard. If I have time, yeah, I do. Maybe mention one more thing then. I said we need steam injection, we need drain, and we need vent. But two of those systems, they already exist on the platform. You have flare systems and you have closed drain. So when we do decommissioning, we will always utilize those systems. It saves us hundreds, if not thousands, of connection points. On Tyra, with 9 installations, it would have been thousands of connection points, interfaces that we could skip. So what we do with the effluents is we drain them through the closed drain system. Even if it's not operational, we will hook in our own pumps, and we will pump that up to our own effluent treatment unit, wastewater treatment unit. In this way, as I said, we save an awful lot of work by utilizing existing systems on board to do that.
Very good.
Which comes back around to early engagement, of course. Start talking to you guys early in the piece so those systems still exist when you get out there to do that work.
Yeah, I think that's very important. The earlier we get in Norway, we very often get very early in, because quite normal in Norway to have studies. We participate in a lot of decommissioning studies. We sit down with other third parties, other suppliers, and we have a certain task from the asset owner to go through, and we will give them input maybe 2-3 years before actual COP.
Very good.
So we've got a couple of minutes left. I've got a couple of questions I've noted down, but if there's any more from the audience, feel free to put them into the chat and we'll get to them. You mentioned a little bit early on in one of your slides about the limitations, things that this doesn't do.
Yeah.
One that stuck with me through that was norms and mercury, but do you want to talk a little more about, I guess, that this isn't a complete silver bullet, but it still does an enormous amount of the work for you?
Everything has a limitation, and definitely with steam too, and that's why we're talking about removing hydrocarbons basically. But maybe I should have a slide about that. We cannot remove, for example, scales, hard scales, calcium carbonate, barium sulfate. We have done some tests and it has an effect on it, but that's pretty novel, and I think for the moment at least, we'll say we cannot remove hard scales. They will remain. So we basically saying this is for hydrocarbons and waxes and that there. And we don't remove norm either. We did have some very interesting results quite recently from Brazil, where we saw norm levels being reduced up to 70% by steam. But it's not because we can flash off norm like we can flash off mercury. It's because the norm is related to particles and solids, and when we steam it, they can be drained out. So we saw quite a good reduction there too, but still, to be conservative, we will say we cannot remove norm.
Very good. And then I guess for a couple of the last minutes here, you were very, very great, really good from a high level through there. Are there any sort of really nuancy technical points that you wanted to maybe loop back around to, given we've got a couple of minutes?
Yeah, I can do something a little bit more technical. Okay, what is the pressure that we will have during steam cleaning? Majority of steam cleaning, one of the things we changed when we started doing this, that we steam on just below 100 degrees. In the old days, they steamed very dry steam, very high temperature, just straight through the vessel. We don't do that anymore. We steam just below 100 degrees, which means that we have 0 bars most of the time on this. And that's because then we condense all the steam and it runs down like really, really hot water inside the internals and do a much better cleaning job. But we do want to have some high temperature periods to take the waxes, which typically have a high melting point. So then we might go up to a bar, 120 degrees, something like that, but never higher than 120 degrees, never. And so it's very low pressures, which is probably why we see so few accidents and incidents too. It's very low. And we never go higher than 120, even if it's decommissioning. We don't want to ruin valves and seats and stuff like that. So I think I mentioned already, we produce roughly 1.5 cube per hour. That's also a good number to have.
Yep.
Brilliant.
Very good.
Look, timing has been absolutely spot on there. I'm seriously impressed. Shaun's clearly sticking to his previous track record of keeping these events running well. So thank you so much, gentlemen. I think this one has been really interesting and clearly setting us up for a couple of future ones as well. But look, this has been brilliant. Thank you both, Shaun and Jan-Erik, for your time on this. For those who've been on the call, thank you. For those watching this later, also thank you for watching it offline. And we will happily share your contact details for anybody to reach out to you. I know, Shaun, you've got your platform, your presence up on our website now as well. So if people want to find your contact details, they can go onto our capability index, and you're all over that for the first point of contact. Wonderful. I'll leave it at there. Thank you so much, everybody, for your time, and yeah, we'll see you on the next one.